The following program is rated GE. It is suitable for general family viewing.
Good evening, ladies and gentlemen, boys and girls. Welcome to an all-new episode of Tech 47, where keeping up with tech is made simple. I am David Ochola, and there's an interesting thought I've had. Information is very important, yeah? And if you think ignorance is bliss, think again. That is exactly why we are here at Geoid Technologies Limited to talk about something that is very interesting. That's survey and technology in the field of survey, because survey really is all about gathering information and using it in different fields to make different things happen. So that said, let's jump right into today's episode. This is Tech 47. Welcome to Tech 47. Tell us who you are and what you do.
My name is Stephen Degwa, Director Geoid Technologies Limited. Geoid Technologies Limited was incorporated in the year 2013 as a surveying company. From that time, we didn't have much knowledge on surveying because we were just from college. But we thought we could do something concerning surveying. And all along, for about 3 years, we were operating as a briefcase company for about 3 years. Then later on, we thought we could do something else apart from surveying, and we identified a gap whereby we had about 3 to 4 companies that were offering technology in surveying. That is selling equipments that are used to gather data in the field, and that data is used in various aspects of surveying that include engineering and all that. We thought we could start by opening a very small office. Actually, it was a 2-room office and 1 staff. By then, we were 3 directors, and we didn't have much fund. After starting, rather opening the office, we could not go far because the equipments that we intended to sell were very, very expensive. And some of them, to mention just but a few, we have a Total Station, we have GNS RTK, we have handheld GPSs, we have theodolites, we have measuring wheels, we also have raging rods, just to mention a few. And all that, for us to be in business, we required about 2 to 3 million to kick off. Fortunately, we approached one manufacturer called Colida. That's the manufacturer we started with. And they promised to support us. And they told us if we are able to make about 10%, they can release the equipment to us. Then we pay balance after we have made a sale. That's how Geoid started, and it was not an easy journey.
Yeah, I can imagine, yeah. So coming from where Geoid was to where you are at, I'm guessing there's a number of things that you've managed to do and, that were required of you in regards to putting in the work, yeah. So what's that one thing that got you from there to where you're at right now?
Before we got to that question, I would like to say that this gap that we realized. Remember, when you talk of land survey and technology, we must know where survey came from. Because we cannot have technology in surveying without mentioning land survey, or rather terrestrial survey. And this is traced way back in 2500 years BC, before Christ. Survey started in Egypt, whereby we have this great pyramid of Giza. They were the first to be built by surveyors, and they were to precision such that they are almost square, and also some few degrees from north-south. When I mention of north-south, we talk of orientation. If you want to know scientifically where you are, you always point to your compass that will give you the direction. You are able to know where your north is, where your south is, east and south. Even when you talk of sun, we normally say the sun comes from east to west. That's the thing we are talking of. That's where survey started.
So that essentially is the primitive version of what was used in survey back then, yeah? So get me from there to where we're at in regards to technology.
From there, it evolved to another gadget called Gantas. Gantas chain. I'll show you that later. From there, we went to steel bud. Steel bud is another equipment that was used to carry out measurements, and you are able to know the distance from one point to the other. Then from there, technology evolved to a machine that is now obsolete, which is called the theodolite, which was used to measure distances and angles. From there, we have other small gadgets here and there that include measuring wheels. That's an equipment that you just hold with your hand, then you walk at it to measure the distance. Then, after that, technology moved a notch higher when the first satellites, or rather satellite was launched in 1957. We can't talk of GPS without talking of satellites, because satellite came first, then GPS came second. Yeah. And by GPS, I mean we have some equipments that uses those satellites to track signal, and they are able to give you measurement in terms of position and also angles.
I just wanted to interrupt you, and even as you talk, what's at the back of my mind is, what's the scope of the things that you do in survey, so that when you're talking about these pieces of equipment, I kind of would know what you're talking about.
Okay.
What would you say entails survey?
Our background being survey, all of us actually, we are all surveyors, and that's the motivation that is driving us to proceed, if I may say. And one thing we do as surveyors is a land survey. Land survey, we can break it into major, or rather into many categories. We have land subdivision and also processing of title, but where technology comes in is the land subdivision, whereby you are able to measure the size of land. And if we have like 10 or several people that need to share the land, you can subdivide into smaller portions using the technology. You can either use the old method or rather use the current technology. We also have engineering surveying. Engineering survey entails construction of roads. We have construction of railway line. We also have construction of buildings and also mining. We also have another survey called hydrographic, or rather bathymetric survey. By hydrographic survey, I mean water survey in a simple language, whereby we have a gadget that is deployed in the sea, or rather in the ocean, or rather in a certain dam, to carry out water survey, and you are able to know the depth of that ocean, or rather the depth of a river, and in any other feature that may be in that water that probably might not be of essential to the work that you are doing. By this, when you collect that water data, you are able to generate nautical charts. Nautical charts are maps that are used by those people who normally operate ships. You also have hydrographic maps that comes out of that. We also have another survey called mining survey. And after that, we also have mapping. Mapping is entirely a different thing but I would not mention them because mapping, we normally do it currently with a very new technology that came about the other day. That is the drone technology. But even the old technology also does mapping, whereby we go to the field, either using the theodolite, which is obsolete at the moment, or at the station. You pick data, you come and process, and you're able to come up with a topographical map, whereby this map is able to show you the topography of an area. If there's tree, you're able to see this is where that tree is located, and also buildings around, where if you have roads passing across, you're able to know the location of those roads. And these maps actually are used by architects and engineers to do some design.
So let's say you have collected data from the field. What do you do with that data from the field?
Once you collect data from the field,
those measurements, those angles you're talking about.
Yes, you go to the office. You first of all do some screening of the data. That we call it cleaning. You clean the data and ensure that data has no errors. Then from there, you start processing. After that, nowadays we are using computers. We are no longer using those manual methods that you used to do there before. But it depends with the equipment that you use to collect the data. If you use the old technology, it means you are going to use the manual way. If you use the new technology, like the hardware GPS, or rather the total station and the GNS RTK, then there's a way we download that data, we insert into a computer. We use a software called Civil 3D, or rather AutoCAD, because there are so many versions of AutoCAD. We also have other software like ArcGIS, ArcMap, and all that are used now to generate this data. You start, either if it was topographical survey, you start analyzing each feature by feature, you classify them, then you come up with a map that represents the same. If it was for purpose of subdivision, you are able to draw the map of that land, the way it is on the ground. Then you feature in all the subdivision that you have done, and you come up totally with a different map apart from a block land. You are able to show all those subplots within that computer. Then from there, once you are satisfied that the map that you have is good and everything is okay, you are able now to print that map to satisfaction. Then if it is a subdivision map, you start by submitting to land survey office, whereby it is given new numbers. Then from there, you take it to land registry, whereby the some plots are given a title deed.
Okay, thank you so much. I think this should be a very interesting conversation, especially when we jump into the tech itself, which we're going to do right after this short break. Be sure to stay tuned. This is Tech 47. Ladies and gentlemen, welcome back to Tech 47, where keeping up with tech is made simple. Earlier during our conversation, we talked about the equipment that is used in survey, and Steven is here with us. He's going to take us through some of the equipment here, and this should make for an interesting conversation, and you will learn one or two new things, just like myself. So I think we can jump into it.
Thank you very much, Bwana Ochola. I want to introduce you to some of the equipment that are used in nowadays technology to capture data. And first of all, I would like to say we have quite a number of dealership with various companies that we deal with. And one of them is Bosch. As you can see, we have this equipment. It is called automatic level. It is from a company called Bosch. We have a dealership with them. We normally distribute these equipments on behalf of Bosch.
So what does that do?
This one is used to collect levels. As I told you, if you want to know maybe the topography of a place, and an architect would want to do a design of maybe a house, maybe how the drainage will flow, how the sewer will flow, this is used to collect that data. Then it is interpreted in the office, and everything is done and come up with a map for the same.
Okay.
We also have this product also from Bosch. There's called measuring wheel. It is used to measure distances. Maybe if you are carrying out engineering work along the road, or rather maybe in an open area where you want to know the distance from one point to the other, you can use this one. As you move, you just drive it. On the ground, it is able to calculate that distance. If you make an error, you can also subtract using the same. The second company that we partner with is Garmin, as you can see.
Okay.
Garmin is the supplier of all hardware GPSs, even including smartwatch that are used for maybe exercises and all that. And these are some of the products that we sell from Garmin. They are used for navigation. You can even trace your whereabouts if you normally go to climb mountains and all that.
Just for the purpose of clarity, these are not phones.
These are not phones. Actually, these are GPSs, so to say. Yeah, they track signal from satellites, and you are able to know your position, or rather where you are, wherever in the world. Okay. Yes. Another company that we have a dealership with is Colinda. Actually, this is our main dealer. We are the authorized representative of Colinda products, the whole Kenya. And we have quite a number of products that we sell for Colinda, and one of them is...
Like, what was that you're holding up?
This one is called data logger. I will explain the work of this one, and it cannot work alone. Yes, I explained to that. This is also another equipment that is from Colinda. It's also used to collect data in the field, to measure distances and also angles. Remember,
what's the name of this?
This is called total station. This is an EDM on itself. You are able to measure distances, and also inside the EDM we have a telescope that is used to measure distances. And this one does not work alone. We have a gadget here.
Okay.
This one is called prism. For this to be able to measure distances, it has to send signal to this prism, and that signal is reflected back to the machine, and the data is interpreted for it to come up with angle to the point and also the distance.
Okay.
Yes. We move on to this other one. This is called a triple prism. Its work is the same as the single prism I just showcased some few minutes ago. And it is used to measure those long distances of a kilometer, whereby if a signal, even if you are not able to see this prism up there, the signal can hit to this one or this one, and still the same signal is reflected to this total station.
Okay.
When we come to now the current technology for GPS, we talk of GNS RTK. At GNS RTK, we have receivers. This one is called rover. This is a GNS rover receiver. And if you can see, it is from our manufacturer, who is called Colinda. And this one, you cannot just have it like this. You normally mount it on this pole. It is a cord carbon fiber pole. You mount it on top. Then you...
What does it do?
This rover, it normally works together with another gadget called base receiver, which is over there. I think I'll be showcasing that in the field, whereby it is able to get corrections from that base receiver. Once you get corrections, you are able to move along maybe a field that you are working on, that you are collecting data, and you are able to get corrected or rather accurate measurement from the field using this. You can also connect the rover receiver on a course stations. By course I mean continuously reference station that is mounted on top of maybe a building, or rather any other place that is doesn't have a lot of interruptions. I'll be showing you that later in the field, whereby that course is fully operational 24 hours. And it uses Wi-Fi and some other receivers so that it transmits signal and corrections to this rover receiver, and you also get corrected measurement from the field accurately. That's the work of this gadget. One thing I would like to say about this technology, you are able to do the work very fast. Maybe a work that you could have done with a total station and you take about 5 to 7 days. In this one, you only take 1 or 2 days. You come to the office, you process the work, and you're able to give your client good data and accurate.
So, is there something else here?
Another gadget I would want to show you is this. This is called the raging rod, and actually this is 1 meter. And the work of this one is to give alignment of maybe 2 points. If you have 1 point from here to the other end, for you to get the alignment, you need this ranging rod. You mount one here. If, for example, you have the other one, you mount there, and the other one at the edge. Then a surveyor would start here, then is able to guide the person who is ahead using some signs. Normally, you use hands. Either you tell that person move either left or right for you to get alignment of that, of those 2 points. Another gadget I would want still to highlight is about this heavy equipment here. This is called the echo sounder. This is the one I was telling you there before, that it is used for water survey, the hydrographic survey. And it normally uses this other gadget called transducer. This is connected to this one. And also, there is a way we connect this controller. As I told you earlier, this is called data logger. When using the GPS, the GNS RTK, you normally use this to record data. Remember, this also record data, but for you to have that uncorrected data, use this one. This can also be connected to this gadget for you to be able to collect data, maybe in the ocean, in the river, or rather maybe in just a small pod, for you to be able to have your data, then come to the office and process. The other gadget that is very vital to our architects and engineers, they are this one. This is a laser distance meter, and for you to be able to capture the measurement from where I'm standing all the way to that end, you can use this gadget very fast. You just put it on, you switch on, you can see there's some measurement here. Yes. Then once I press here once, you see it has a laser. I'm able to get the measurement. You see?
Yeah.
Now from where I stand to that end, this is 5.4 meters. This is used mostly by engineers and architects to get maybe the width of a room, maybe from one end to the other, and they are able to calculate the area within that room.
Without having to do it manually?
Yeah, they don't have to do it manually. And we have quite a number of them, and they range in different categories. This, I think, is 50 meters. We also have for 100 meters, 120 is the last graduation. We also have this other gadget called the line laser. This one can also be used by engineers and those people who do building plastering. Remember, if you want to get a very good line where you are going to maybe to do something, or rather even mounting the posters that you are seeing, for you to get this level or rather this line equal to that one, you can also use this gadget. I'm going to switch on like this. Then if you mount it here, you can see there's some laser, and you are able to get that line all the way to that edge. So even if it is someone painting different colors, maybe you want to paint black below, then red or rather any other color may it be on the top, you are guided by that line. You can't go beyond that line. Other than this, we call it this manual way, whereby you have to put a line there, then you draw. Yeah, this one make the work easier for architect and surveyors. One thing on the, or rather last but not least, I'd want to say technology is the way to go. Remember, apart from some of these gadgets which are a bit obsolete, a gadget like this one, there's a measuring wheel that I was talking of. It is latest technology. Other than for you going to the field, then use your legs to pace. Yes. You can use this one very fast if it's just a matter of knowing what the measurement from this point to the edge. Another thing I would want to say is the GNS RTK. It is making work very easy, and it is a high time for surveyors to embrace this technology, because if you don't want to lose jobs, nowadays we are saying delivery is the key thing. Yes. If you don't deliver, you don't get your dues. You have to ensure when given, you save first of all time, you save money, then you deliver within the reasonable time so that client is able even to give you more jobs and also referrals. Remember, if you stay with work for a long time, a client will say, I know, this guy worked for 2 weeks and it was just a small job, and I have another one, I just refer another surveyor to do it. But for example, if you go with a tape at this tape measure and this raging rod, and remember, there are some bushes probably if you are doing subdivision in a certain parcel of land, and you encounter maybe some trees along the way. Remember, you have to call people to cut down that line for you to be able to get the visibility of that line. Yes. But with the GPS, you don't have to do that. You just go straight to the point, and you are able to identify this the point that I want, and you are able to do or rather to place your beacon. Yes. Yes.
Thank you so much for taking us through this. We really appreciate your time. Ladies and gentlemen, as we always say on Tech 47, tech is all about making things simpler, things faster, things more efficient. You want to keep watching Tech 47 every Saturday from 6:30 p.m. because if you don't see it on Tech 47, then it technically did not happen. See you next week, same time, same place.